Now in this case, we're going to be discussing confidence intervals for the mean, and that will be followed by confidence intervals for dichotomous outcome. First, we'll start with continuous outcomes for one sample. Now, this is an important fact. If n is greater or equal to 30, then we use z to find our confidence interval. However, if n is less than 30, we use t to find our confidence interval, and then both formulas are laid down there, which were x bar, which represents the mean, plus or minus the z value, which is found in your textbook. Usually in the back of the textbook you have z values, s, which is our standard deviation, and t will be the t value there, and that will be as well found in the back of the book, and n, which is the number of samples. So as we continue, in a study n equals 3,534, the mean systolic blood pressure was 127.3 with a standard deviation of 19. Generate a 95% confidence interval for the true mean systolic blood pressure. So in this case, n here was represented by 3,534, which is definitely greater or equal to 30. Then we're using the z formula. So in this case, as we can see here, we use the mean systolic blood pressure, which was 127.3, plus or minus, when you look at the table, the z value there is 1.96, which is then multiplied by 19, which is our standard deviation, and for the square root of n, which is 3,534. For dichotomous outcomes, here confidence interval for one sample, and first of all we have to establish a minimum. Now here we need to make sure that n times probability here, and n parenthesis 1 minus p is greater or equal to 5. Now in most problems, of course, we want you to find the confidence interval, so it will always be true in most problems, unless indicated otherwise. So here, the probability here to find the confidence interval will be p plus or minus z, which we know where to find it, square root of p, 1 minus p over n. Now, in this particular case, it's important to understand what you're given and what you're looking for. So in this problem, confidence interval for p, in a study, n equals 3,532, 1,219 patients were on antihypertensive medication. Okay, now we need to generate a 95% confidence interval for the true proportion. So that's the word right there. So different from the mean, we're looking for the true proportion on antihypertensive medication. Now over here, we have two things to do. We need to find, first we'll find the proportion, and then find the true proportion by using confidence interval formula. So here for the proportion of course will be x over n. So x will be that particular subpopulation that we're looking for. So here, how many patients were on the antihypertensive medication? There are 1,219. So we'll divide that by the total population, which will give us p equals 0.345. Then we'll use the formula to evaluate what the confidence interval is in this particular case. And as we can see, z is 1.95 because we're looking for 95% confidence interval, and that will give you what z value is. For other confidence intervals, as you can see on the table, it will give you other values or variables for it. And at the end, then we can evaluate that true proportion to be between 0.329 and 0.361.